So here I am again. Okay, and we will begin with exact trig values. All right. Never seems to enable me to write or allow me to write. Okay, fine. There we go. Better. And maximize and done. Okay, so what does this mean? Exact trig values. Trig values of special angles. So the trigonometric functions that you learn about are sine, cosine, and tangent, although there are three others, secant, cosecant, and cotangent. And the sort of special values that you learn are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And this table, you can learn it off by heart, or you can learn the argument for each of them and the logic behind them. It's better to learn the logic behind something, and then you've earned learning it off by heart. Roughly speaking, though, sine and cosine are about sine and cosine are functions that were built for the right angle triangle whose longest side, hypotenuse, has a length of 1. And, you know, we have this focus angle down here in the corner, and we don't know what it is. Let's just say it's 37 degrees, for example. And sine and cosine were built to tell us the length of these sides, the opposite side to the angle and the adjacent side to the angle. The sine function, when you feed in the angle 37, it tells you the exact length of that side that is opposite the focus angle. And the cosine function, when you feed in 37 degrees, it will tell you the adjacent side, the length of the adjacent side to that focus angle right there. And then, of course, for every other right angle triangle, it's just a scaled up or scaled down version of a unit right angle triangle. And then every other single triangle in existence can just be broken down into a pair of right angled triangles. And so this is a proper starting place for trigonometry. Anyway, sine of 0 degrees, going by this sort of quick picture that I drew, would logically be 0. Of course. Sine of 90 degrees, if you imagine the triangle getting taller and skinnier and taller and skinnier, it would logically then be 1. And for cosine, it would be the reverse situation. If this focus angle here were 45 degrees, then the opposite and adjacent sides would be exactly equal in length, and therefore sine of 45 degrees equals cosine of 45 degrees. And we can use the Pythagorean theorem here and just say that x squared at x squared equals 1, or in other words, 2x squared equals 1, or in other words, x squared equals a half. And if x squared is a half, then x is the square root of a half. Rationalizing the denominator, we get root 2 over 2. Some other reasoning, which I don't have time or desire to go into here, sort of enables you to find out that sine of 30 degrees is a half and sine of 60 degrees is root 3 over 2. And then for the cosine case, it will be the reverse. The tangent of theta can be defined geometrically using a rather complicated picture to set up. But there is another definition. There is a way to define tangent such that it's the that it's sine of theta divided by cosine of theta. And employing this definition here, we can just divide the top row by the bottom row to get this row here. And so 0 divided by 1 is 0. A half divided by root 3 over 2 is 1 over root 3. Root 2 over 2 divided by itself is, of course, 1. This here is root 3, being the reciprocal of that. And then 1 divided by 0, well, that's undefined, although some people think of it as infinity somehow. So you need to memorize these values just to even get started, and then to go beyond just 0 to 90 degrees, understand that sine and cosine are periodic. They have periods of 360 degrees, both of them do. And you should memorize the shape of the trig values, like their graphs, rather. The trig function graphs. They all look like this. That's for the sine function, whose maximum is 1, whose minimum is -1, and there is 90 degrees, there is 180, there is 270, and there is 360. Cosine is that, but translated to the left by 90 degrees. And then tangent has a period of 180. But this will all be familiar to everyone. Now we should try solving these problems here. Find the exact value of each trigonometric function. So 30 questions here. So I'll handle 5 at a time, why not? Tangent of 60 degrees, as we've just seen, is root 3. Sine of 225 degrees, well, okay, so you should find this angle here, which you may call, which is called the reference angle. That's the angle that it makes with the horizontal. And in this case, it's 45 degrees. So it's going to be the negative of sine of 45 degrees. Which is negative root 2 over 2. Sine of 90 degrees is exactly 1. Cosine of 150 degrees. Well, notice this is 60 more than 90. So we sort of go down by 60 there, and I'm just sort of visualizing it. So negative root 3 over 2. And cosine of 90 degrees is 0. And tangent of 200, I should do 6 at a time. Tangent of 240 degrees. Well, 0 at 0, and then shoots off to 90, and then wraps back around, comes up 180, and 60 more. And what's tan of 60? That is root 3. Right, so let me check those. Okay, root 3 is correct. Negative root 2 over 2 is correct. Root 1 is correct. Negative root 3 over 2 is correct. 0 and root 3 are correct. Next up, cosine of 135 degrees. So I believe it's negative root 2 over 2. Tangent of 150 degrees. It's on by 60. So the minus 30, so the minus of tan 30, so minus 1 over root 3. To be completely frank, just visualize the graphs for a lot of these things and deploy kind of cheap tricks. Cosine of 270 degrees, 0. Tangent of 225 degrees, 1. All right, so I'll check that these are all correct. Negative root 2 over 2, that's right. Rationalizing if I were. Zero, and that's 1. Okay. All right, cosine of 270. We'll check once we've reached 16th. 0. Sine of 0, 0. Cotangent of 7 pi over 4. Cosecant of 2 pi over 3. Cosecant of 225 degrees. Sine of 300 degrees. Okay, I'll check these now. 0, 0. Negative 1. Right, of course. Rationalizing the denominator. Okay. That's correct. Cosecant of 90 degrees is 1 over sine of 90 degrees. Sine of 90 degrees is 1, and so it's just 1. Tan of 240 degrees. Sine of pi over 4. Sine of 45 degrees, that's tan of 120 degrees. One root 3, root 2 over 2, negative root 3. Right, okay. Cosine of 630 degrees. Well, 630 degrees that's 270 degrees. So it's the negative. No, it's the same as cosine of 270 degrees, which is 0. Okay, so I'll just go up to 24 and then check. Okay, so this is 1 over sine of first. Thirty-one pi over 6 is equal to sine of 31 pi over 6 is the same as sine of pi over 6. The sine of pi over 6 is the same as 30 degrees. And 30 degrees, sine of 30 degrees rather, is a half. So 1 over a half, so negative 2. Right, now to check. 17 and 18. Correct. 19 and 20. Correct. 21 and 22. Correct. 23, 24. 24 is wrong, but why? Okay. Cosecant of negative 31 pi over 6. That is indeed 1 over sine of 31 pi over 6. And sine of negative x is indeed the negative of sine of x. So what has gone wrong here? Oh, of course. You see, 31 pi over 6 is 5 and 1/6 of pi. 5 and 1/6 of pi, which, when you subtract 4 pi, gives 1 and 1/6 of pi. 1 and 1/6 of pi, or in other words, 7/6 of pi. 7/6 of pi. Seven pi over 6. And you calculate, not forgetting the minus sign, and that is indeed negative half down here, which, so it evaluates positive 2. I see the error. No problem at all. Okay. Cosecant of negative 5 pi over 6. Right, so that is 1 over sine. Sine of what? So I switch it back to degrees. Negative 150. Which is negative 1 sine of 150. And what is sine of 150? It's the same thing as sine of 30. So that's a half. So it's negative 2. This is the exact same thing as cosine of 17 pi over 3, as cosine is an even function. And then you must figure out how many 2 pi's fit into 17 pi over 6, 17 pi over 3. Well, 17 pi over 3 is 5 and 2/3 of pi, and therefore subtract 4 pi, and then you get 1 and 2/3 of pi, which is 5 pi over 3. So it's asking for the cosine of 5 pi over 3. And that is well, it's the cosine of it's a cosine of 300 degrees, which is the cosine of 30 degrees, which is no, that's not right. That's not right. $180, $270. I mean, it's a half. I know it's a half. I can just see it. Okay. Sine of 29 pi over 6. Well, that's the same as 4 and 5 over 6. 4 and 5/6 of pi. So 5/6 of pi. And 5/6 of pi is 150 degrees. So it's a half. $225. What is cosine of 225 degrees? Negative root 2 over 2. So negative 2 over root 2. Which is negative root 2. Cosine of negative 11 pi over 2 is the same thing as negative cosine of 11 pi over 2. And 11 pi over 2 is the same thing as 5.5 pi. Take off 4 pi, and then you get 1.5 pi. 1.5 pi, which is 270 degrees. And what's cosine of 270 degrees? 0. And so it's 0. And then the sine of negative 2 pi, well, that would be the same thing as the negative of sine of 2 pi. But sine of 2 pi is just 0. So 0. Now we must check. 25 and 26, we're in agreement. 27, 28, it's agreed. And 29 and 30, it's agreed. So all is well. Next, the law of sines. Okay, so there's 28 questions, but let's see. So the law of sines enables you to find a missing side length or missing angle of a scalene triangle under certain conditions. If I just draw an arbitrary scalene triangle here, 1, 2, 3, and I allow the angles to be called A, B, C, and the sides shall be named AB, little a, little b, and little c, but in a precise way. This side, the side connecting vertices B and C, or the vertex of the angles B and C, shall be called little a. And the reason why is because it is the side that is opposite angle A. So this side here should be called little b, and little b shall also stand for its length, and this side here should be called little c, and little c will also stand for its length. These are called side angle pairs. I will just point out one of them so that it's clear. Angle A is paired with side A. There. And perhaps just another one. Angle B in blue is paired with side B. And we'll just do the last one for completeness sake. Angle C is paired with side C. The side angle pairs are related in a very special way. It turns out that the length of A divided by the sine of angle A is exactly equal to the length of B divided by the sine of B, which is also exactly equal to the length of C divided by the sine of angle C. And therefore, if we have a complete side angle pair, and an incomplete side angle pair, then we can complete the incomplete side angle pair. For example, if I know the length of side A and the size of angle big A, like let's just say 18 centimeters, 37 degrees. And for side B and angle B, I know one of them, but I don't know the other one. For example, let's just pretend that I know the side of length B, but I don't know the size of angle B. Then I can complete this, and I can actually find this out based on these three bits of information. That one, and that one, there. And the sine rule, and I can actually work it out. I can actually work it out. So in this case, it would be the statement that, just plugging things in, plugging 18 in where A is, and 37 where angle A is, and 11 where side B is, and question mark where B is? No, just B where B is, like this. Now, I can use algebra to rearrange this and get B by itself and actually find out how big that angle is. So how would I do that? Well, in this case, when you have two fractions that are equal to each other, you can flip them. For example, if 2/3 is equal to 4/6, then you can flip them. And 3/2 is the same as 6/4, and that's true. Except if 0 is on the top, of course. Okay, so flip them. Flipping the left, flipping the right. Cross multiply, as in multiply both sides by 11. So 11 comes up here, and sine of B stays over there. Then arc sine both sides to get B by itself. So B is the arc sine of 11 times sine of 37 degrees, all divided by 18. And if I work that out on my calculator, and I would need my calculator for this, you get about 21.58 degrees. Okay. Okay. Now to apply it to these questions here and to round my answers to the nearest tenth. Okay, so like I say, there's 28 questions, so we better get going. Okay, we have to find the length of AC, and we have okay, find the missing angle C over here. So 118 plus 22 is 140, so this angle here is 40 degrees. So now length AC is equal to we must do it to the nearest tenth, so do it. $13.98, and thus we say 14.0 to acknowledge that we did round it to the nearest tenth. Next up, find AB. Well, the length of AB will be this. Very close to a right angle triangle here. Oh, no, it's exactly a right angle triangle. All right, so we could use right angle trigonometry, but just to indulge them, okay. Okay. Damn it. 29.1. Okay, better check these first four. 14, 8, 17, 29. Oh, darn it. How could I not see that that was false? Okay. No problem. There is a problem. Just try to do better. Okay, so the length of BC divided by the sine of 39 degrees equals the length of 27 divided by the sine of 90 degrees. So it's actually supposed to be 27 sine 39. Spell it out when you don't get it. 16.99, which is about 17.0, and that's better. Right, get these right. Find the length of BC. Very well. BC. The length of BC over sine of 93 equals the length of AC over that's 151 then, so that's 39. Okay, so work out all the angles first. The length of BC over the sine of 93 is the length of 16 over the sine of 39. So the length of BC over the sine of 93 is the length of 16 over the sine of 39. So bring that up. Good. Now for this one, we'll work them all out in the end. Find MC. I don't know what that means. I think that means the size of angle C. But I don't know what this weird way of writing it is. Never seen that before. Anyhow, let's just proceed forward with it. So we can say for sure that sine of angle C over 21 is equal to sine of 88 over 26. And therefore, bring that up. So C is the arcsine of 21 sine 88 all over 26. Here, sine of C over 20 equals sine of 82 over 29. So C is the arcsine of 20 sine 82 over 29. And here so I believe it's about that. So 25.4-ish. Okay. $53.8. $43.1. $13.0. So now to check these. 30. Darn it. How is that possible? Okay, the others are fine, but why is this one wrong? The length of BC with the sine of 93 is 16 over the sine of that's 151. Oh, 29. Goodness me. You know what? I really do need to start doing some arithmetic practice. I've somewhat slacked with it lately. There we go. Better. 33. You must care about accuracy. Okay. Find the size of angle A. So, supposedly, sine of angle A over 11 is equal to a sine of 129 degrees over 25. So A is the arcsine of 11 sine 129 over 25. Now, when you do this, you get an answer of 20 degrees. And finally, the sides of angle C. Okay, so sine of C over 19 equals sine of 97 degrees over 22. So C is arc sine 19 It's about 59. Check them. Yeah, that's all correct. Now, in these next questions, we are to solve each triangle. What does that mean? That means find every single missing length and missing angle of the triangle. Okay, so what would that practically mean? Well, first of all, just, okay, first, perhaps make the pen smaller. Okay, so angle C will be the arc sine of 26 sine 70 all over 25, which is about 77.8. Now that we have angle C, of course, we then can get angle B. So what I'm going to do is I'm going to type in answer. So I'm going to type in 180 minus answer plus 70. And this gives me angle B correct to the nearest tenth. So I can do that little angle symbol. 32.2. Now you have angle A, C, and B, but we've only got sides C and A. So how to get side B? Well, side B over the sine of that angle right there is equal to the sine of 70 over, no, side B over the sine of that angle right there is equal to 25 over the sine of that angle right there. So we can use this information without losing any accuracy. We just need to be careful about it. Right, 25 there. Sine of 70 degrees there. And then put sine of answer there. So I type in 25 times the sine of my answer, and I divide it by the sine of 70, And on paper, though, here, I'm going to type in that there. And I'll get 14.2. So let's just see if I got that right. Okay, so a subtlety arises, and you need to understand that subtlety, not just lazily glide over it and just say, well, you know, I got one answer. There's an alternative answer that's possible. And why is that the case? Because this is not a sufficient amount of information to uniquely specify the triangle. So what does it say here? It says A70, C26. There's A down in the corner. Here's side A, you know, in the appropriate position opposite to it. It could be there, or it could be there. Where's C? C has to be here then. And therefore, it's either that one, that could be angle C, or that could be angle C. We have an obtuse and an acute possibility, so I'll call that C prime. And that could be B, and that could be angle B. No, I didn't mean to double that. Okay. So that's the truth. And you know, how to actually get that. Well, it's when we get this missing angle C here, the other possibility is that it will be the what's the word for when they both add up to 180? I always get these mixed up. Complementary, supplementary, explementary. I always get them mixed up. Okay, they will be supplementary. Supplementary. It's complementary when they add up to 90 degrees. Make sure it kind of looks like a C, 90 degrees. Supplementary, like a sunset. And then explementary for when you like go around. Okay, fine. So the other possibility then is yeah, the other set as recently given. But how to detect when we have multiple answers? Right, so it must be tried with this here. All right, so we're told that 28 over sine A is 27 over sine 45. Forget that it's special for now. Just forget it. Why the hell did I put that on top? On the bottom, rather. Sine of A over 28 equals sine 45 over 27. So get it. That. Now, $47.16 is a possibility. Then we obtain angle C from that. By doing 180, take away the answer plus 45, so we get 87.8. That's to the nearest tenth. Then we need side C. Side C over the sine of that answer that we just obtained is equal to, use the information that we've already got. $38.2. It's one possibility. Now, B is down in the corner. 27 is opposite that. So it could be like that, or it could be like that. So to get the other one, what we're going to do is type that in again. Then we'll do 180, take away that answer, and then we'll get this other possibility here. This is how I believe that it works, but I'll check in a second. Then angle C becomes 180, take away that answer that we just obtained, plus 45. So like an incredibly tiny, tiny angle. .2 degrees, but it's still an angle. And the length of side C becomes what? The length of side C becomes what? that is basically nothing. It's very tiny indeed. Okay, now to check. Okay, we're in agreement on the first lot and second lot. Yes, we're in agreement, but we differ on the last measurement. But I know that mine is actually more accurate because I fed in the previous answers. So their algorithm is wrong. I do not take satisfaction in that. Or I do. Okay. Now, then there's only one possibility. There's only one possibility. So, I see it now. .0. That's to the nearest tenth. But of course, I'm going to keep it for as long as I can. .28. And A, side A, .27. Okay, good. Now the next one, I couldn't help but sneak peek, so apparently I know ahead of time that this is not a triangle. Sorry, it was just right in front of my eyes. But I have to come up with reasons why this is not a triangle. Well, I mean, it's going to involve the triangle inequality, something like that. But first, let's just follow the maths because it should come up with an error, right? Also, we want to see what would happen if we just did apply the maths. Well, that would be the arc sine of, and then bring up A here. I see. That's going to be bigger than 1. And so that won't work. And we'll check. Math error. See? That's brilliant. Good. Okay. No, I want to understand it. I don't want that. B is 73, A is 7, B is 5. Okay. Well, okay. One of these is 7. It's that one, or it's that one. Basically, I'm saying that you can't get 5. Like if you hang down 5 like a pendulum like that, it'll miss it. No, when it's 90 degrees, like basically that's the best case scenario that you have. And if you have a right angle triangle, so basically, can you have a right angle triangle whose focus angle is 73 degrees, and that length there is 1, and that length there is 5 over 7? Is that actually possible? And of course, that's not possible because sine of 73 degrees damn it. Thought I understood it then. Okay, I guess I don't. I'm just dividing everything through by 7. Okay, maybe I'm just not going to get it just this very second. That's fine. So I will actually move past these 4 here. Or maybe I won't. Put in effort. Okay, so right, so let's get sine of angle A. Let's get angle A rather. So angle A is the arc sine. Is that 22. That angle there, we do 180. Take away the sum of that angle, plus 117, to get, well, 41.0. Then what? Then we want side C. So side C over the sine of that angle there, so 38. Come on. Okay. And I think that's the only one possible for that. Okay, because 18 over 9 is obviously 2, so not a triangle. Okay. Well, here we find out that B is all right. So I'll check these now. Yeah, these are all correct. All right. Okay, so I want an algorithm for this. Whatever this is, state the number of possible triangles that can be formed using the given measurements. So there's a triangle inequality, but that's not going to come in handy here because it's not just 3 lengths. It is instead this. So how to do this efficiently? Okay, first just try to find one, whatever the case. Like, for example, so find angle B. Okay, angle B is arc sine. Right. $41.9 degrees. On then, isn't it? Based on that, yes. Okay. Right, and here was my reasoning. I did 180 take away 41.9. That gave me like something like 138 point something, and then you add 6 and you get something in excess of 180. So that triangle is not actually possible. So only that triangle there that I've just sort of found one angle of is possible. So we're going to follow the same sort of thing here. So we'll find angle A. Angle A shall be sine of angle A over A. this. $41.94, or again 41.9. $180. Take away that answer is $105. So 2? Yes. So we get 20.9. So that should be one triangle. Yes. Okay. So one triangle is possible. Good. We need to take away that. So I think 2, but the other one's really small. Yes. Okay, good. Come on, quicker. None. You cannot. Okay, good. Now, to find the area of each triangle to the nearest tenth, and for that we use what's known as the area rule, and it says that the area of a triangle is half of BC multiplied by the sine of A, where B and C are just any two sides of the triangle in question, and A is the angle between them. So in this particular case, it would be half of 11 squared. The black electric toothbrush. And the toothpaste as well. Units, please. That many square kilometers, 12.0 square kilometers. So 30 times sine of 50, 23.0. Okay, that's all. And now the law of cosines. But just prior to that, we'll take a very short break. Let's see how many. Okay, so this is fiddly work. Can I turn the camera off or what? Suppose I could just do this. That's one way to solve the problem. So I'll be back momentarily. So I'm back. Okay. Law of cosines. So let's remind ourselves of how this goes. The law of cosines says that for a completely arbitrary, made up triangle, which if you just make one up at random is going to be scalene, for a completely random triangle whose angles are called big A, big B, and big C, and whose sides are called little a, little b, little c, and just remember how we do that, like systematically. We call this side here, which is opposite angle A, we call that little a. And this side here, little b. And this side here, little c. Here's what the law of cosines says. It says this. Wait, is that the Pythagorean theorem? Kind of. It's what it's built on. Minus 2bc times the cosine of A. So remember that, like, little a is a name for this side, and it also stands for its length. Yeah? So if I say side A, and if I say A equals 11, it's understood what that means. I'm referring to the length of side A. Okay. Anyway, it's saying that the square of the length of this side is equal to the square of the length of this side plus the square of the length of this side, take away 2 times b times c times by the cosine of the angle between them. Okay. So this is a very powerful theorem. It enables you to find the length of a missing side when you know the length of the two other sides and the size of the angle between them. It lets you find this red length here when you know the length of the blue and the length of the green and the angle in red. Alternatively, you can rearrange this so that you find out a missing angle using 3 sides. So I will take away b squared and take away c squared from both sides. And then I'll divide both sides by negative 2bc. And that will look like this. And that is going to equal the cosine of A, and therefore angle A, is the arc cosine of this massive thing right here. So it lets you find a missing side length or a missing angle. And let's put it into action. Okay, so here. Okay, so we have to do it to the nearest tenth. So we have to find AB. So that will be 29 squared at 13 squared. Well, this is just applying the law of cosines. 29 squared at 13 squared, take away 2 times 29 times 13. times by the cosine of the angle between them. All of that is whatever the length of AB is squared, and therefore I must square root it. The way that you can make this more fun for yourself is to know what the sides of the lengths is to know the squares of numbers. So 29 squared is 841, 13 squared is 169, and add them together. So you get 841 turns into 941, 1001, and then 1010. 1010. Take away 2 times 29 times 13. So 29 times 13 is 377. Double it, and you get 754. But cosine of 41, not going to be able to do that in your head. You know it's nearly root 2 over 2, but good luck doing that in your head. So the answer is 20.99, which to the nearest 10. Hooray. Okay. So we have all the others to do. My goodness me. Right, okay, I'm going to be selective about this because this is very formulaic. So the length of BC is 21 squared, 630, so 1260 times the cosine of 123. So it's the square root of 1341. Take 1260, cosine 123, 45. Okay, so angle B here is going to require a little bit more thought. Right. Right. So apply the sine rule to get BC first. The length of BC divided by the sine of A. What the hell? Why is not working? Oh, goodness me. Goodness me. It's cosine rule. It's fine. It's fine. It's absolutely fine. 22 squared, 484. 17 squared, 289. Take away 2 times 22 times 17 times by the cosine of 143. So that gives me 37 for the opposite to the nearest tenth, but I will use that figure to get the angle B somehow. Well, now it is the now it is the cosine rule, but now it is the sine rule, but I just didn't realize it before. Okay, so the sine of angle B over the length of AC, so that's arc sine of so bring that up and arc sine it. Okay, so over 37, or rather over the answer. So 16.1 degrees to the nearest 10. All right, find angle A. By the cosine rule, so we do root 841 plus 784, take 2 times 29 times 28 times by the cosine of 52. And we get about 25-ish, 25-ish. Very close to 25, stunningly close. And then we find out that the angle A is the arc sine of the size of BC, so 29, times by what angle information do we have? Sine of 52 over, well, that's going to be called ants. Yeah, I like this idea of just asserting that, you know, I'm working with the prior answer. 29 times sine of 52 over the answer. So 66.1. Now to find the size of angle C, that guy right there. So find AC first. Cosine rule. 29 squared is 841. 24 squared is 576. And take away 2 times 24 times 29. And I want to do that in my head just for fun. I beg your pardon, 24 times 29, come on. 696, and you double it. Okay, and you got 1392. All that times by the cosine of 101. So you get 41 point whatever. I put a tilde in front to say approximate. Now angle C. $35.1. Yeah, I like it. Angle A now, please. Okay, so this is cosine rule, but like in this way. Arc cosine of 100 take 289 take 121 all over now. -2 times 11 times 17. And we get 34 degrees. Size of angle A in this case, well, you're going to have to do cosine rule to get the size of AB. (31-ish). And applying that answer now to get the size of angle. No, to get the, yes, to get the size of angle. Right, okay, just say 31 here. Now to get the size of angle A. That will be approximately, by the sine rule, okay, so it'd be the arc side of 20. Okay, now to, this is crazy. Solve each triangle. Well, try for these. Okay, I'm going to check these so far. That's good. 7, 9, that. Right, okay, that's fine and fair enough for this board at that point. Right, so we'll mark that off. That has been solved. So we'll stop just for now. Be well.